In this video, let's discuss Euclidean algorithm, which is a method for computing the greatest common divisor of two integers. So we have, say for example, 8 and 2. We'll have a GCD of 2. And one more example, say 5 and 3. Will give us a common divisor of greatest common divisor of 1. So Euclidean algorithm will simply repeatedly apply the division algorithm, where A is the dividend and B is the divisor, Q will be the quotient, and R is the remainder. So in the first step, we're going to apply the GCD of A with B, and basically the assumption here is A greater than B. Afterwards, you will get the GCD of B, the smaller number, with its remainder of the previous division. And after that, it's just repetition now. So we will be recycling the remainder of the previous operation and using it as our dividend, and the cycle repeats. So let's illustrate this with an example. So we have 5 and 3. So let's choose simple examples. GCD of 5 and 3. So first application of division will be 5, the dividend, and its divisor will be 3. The quotient will be simply 1, and plus 2 will give you 5. So after that, this divisor will be used as a dividend, and the remainder will be used as the divisor. So this will be 3, and then divided by 2. So you will still get 1 quotient, remainder of 1. And we will do this until we get a remainder 0. So that will be our termination Q when this remainder here becomes 0. So again, the divisor from the previous division will become the dividend, and the remainder of the previous division will be the divisor. So in this case, 2 over 1, which is 2 quotient, and this is the Q for termination now. The remainder became 0, and the answer will be the last remainder before it became 0. So the last remainder before it became 0 is 1. So therefore, this will be your answer. GCD will be equals to 1. So let's try a slightly complicated example from the book. Say find the GCD of 414 and 662 using Euclidean algorithm. So again, let's do this using repetitive division. So you have, for example, 662 divided by 414, and the quotient will be 1 with the remainder of 248. Then same drill, we're going to use the previous divisor as the dividend. This will be now 414, and we're going to divide it by the previous remainder, which is 248, giving us another 1 with a remainder of 166. Same drill, 248 will become now the dividend, and the previous remainder 166 will be our divisor. So this amounts to 1 still, plus 82. Okay, repeat. This will be 166 equals to 82, and 82 times 2, okay, 264. Okay, so this 2 plus 2, almost there. So the remainder became very small already. Let's apply this one last time. 82, the divisor is 2, and we will get a 41, giving us a remainder of 0. So this is again the cue for termination, when the remainder becomes 0. So the number prior to that, the remainder prior to that, which is 2, is now our answer. So this is our answer. GCD 662414 is equals to 2. Okay, so with this we could come up with another way of doing this will be using the modulo operator. So we could have a repetitive modulo operation. Say if we have numbers GCD A and B, again let's just assume that A will represent the greater integer 662 for example, and B will be for the smaller. So to get the 248, that is basically A modulo B, will give us the 248. Is 248. Let's use another pen for it. So A modulo B is 248. Okay, that is 662 modulo 414. And then next will be another A modulo B. So let's just give this a name. So 248 basically was assigned to B, while your previous B was assigned to A. So the way to analyze this is, let's come up with a simple notation of assignment. Say our B was assigned to A, and that is this previous B 414 became A, and the remainder became B. So the remainder which is the modulo, this is the remainder, became b. And afterwards, it's basically now a loop. So we are repeating this operation over and over again. So the next modulo will be 414 modulo 248, which gave us 166. So this became 166 in the next loop. And same drill, we're going to assign 248 as our B, and then 166 as our A, and then 166 became our B. And then we are going to repeat the process again, this time with 248 and 166, and the result now became, the modulo result became 82, and so on. Thus, we could come up with an algorithm. This will be a while loop basically, where the condition of termination, so this will be a while loop, and let's have the condition for termination will be remainder is not 0, or since we assigned the remainder to b, we could say while b is not 0. So while b is not 0, we will still perform the modulo, getting the remainder, assignment, and putting the remainder to b. This can be summarized in the following pseudocode. So our precondition is we are accepting positive integers, and we could assign the larger one to x and the smaller one to y. So while y is not equal to 0, we will repeatedly apply the modulo operation and the assignment operator. And afterwards, we're going to provide the GCD to be the x. This is again the last remainder before it became 0. So the last remainder is the GCD. So let's try to code this one. Let's open this in Visual Studio. Say I have an GCD, and let me accept two numbers, so int a, int b, and for that I have a choice if I could repeat I could assign or not assign. Let's try not assigning. So let me just say while b is not 0, I will repeat the remainder. So let me declare the remainder, int remainder, and let's assign the first remainder to be equals to a modulo b. Again, I'm assuming here that a is the larger integer. So it's part of the precondition of our algorithm. So a assign b to a afterwards, and assign the remainder to our b. Assign the remainder to our b. And afterwards, we're going to return the result. So return a. Okay, so let's try to call this on the same number, 662 and 414. So let's print this one. Printf the GCD of, say, 414,616, is it 616, and 414, okay, 662. So 662 and 414 is equals to %B new line. So GCD 662 414. Let's just verify this again. So I just called two numbers and terminate when the remainder is 0. Get the remainder of the two numbers and assign B to A, assign the remainder to B. Okay, let's run this one. And there you have it. The GCD of 662 and 414 is equals to 2. Let's try another number just for another checking. Maybe the 5, the smaller number, 5 and 3 should give me 1. So 5 and 3. Okay, so I think the algorithm works.